So I thought I'll quickly do a test of the new RTK setup. I've shifted to a different private RTK service provider over NTRIP, and so I'm just checking the accuracy of it. I was previously using the Survey of India's course base stations, but that seems to be a little unreliable at this point. And the main idea about this is I have the base station right here on top of my house, and I'm going to head to my Jeep now, the control station. This is my setup. So as soon as I turn this on, you can see that the RTK is giving me a red sign. It's converging the satellites. It says not connected. So the satellites are not converging yet. And for this, what I'm going to do is take off the flight by turning off the RTK mode. What that will do is allow me to take off, and then I'm going to reconnect the RTK and see if it converges. Okay, had some issues with the RTK connection, but now I've connected to my dongle and I've recharged it. DJI Pilot 2, let's enter the camera view. So I'm going to turn off RTK.
Taking off. Home point updated. Check map to confirm.
Okay, so I had another error. So this is the technical challenges you would face. So the RTK was not converging, and what I did was I landed the drone, and I knew one of the two devices, either the RC or the drone, has to be restarted. So I restarted the RC, and the drone is still on and it's on the landing pad, and this seems to have initiated the converging of the RTK service. So I'm going to take flight now. Okay, so now we have started the mission. This is going to take about 9 minutes, and I've got the big screen here to help me to keep track of things. After processing the mapping mission using WebODM, we have some stats. The average ground sampling distance is 3.3 centimeters, which means that 3.3 centimeters on the ground is represented as 1 pixel. The errors are 0.01 meters, which is 1 centimeter. This is the best accuracy I've got. And this is also because of the proximity to the base station. As I mentioned earlier, I have the base station set up right above my house, and other people within a 20-kilometer radius, if they have subscribed to this NTRIP service, RTK service, would be using corrections from my base station, and it's basically part of a blockchain, so it's very interesting there. These numbers are really good. So as you can see, the GPS errors, the total RMS error is about 1.5 centimeters. So we have all these details of the data collection through the WebODM report. And then we finally end up with this high resolution map from the drone mapping mission. The backdrop is a Google Maps satellite view. So this is where I had taken off from, and you can see this is the drone imagery, which is very high resolution. These are the coffee trees, and there's some shade trees on top. So with this high level view, what we can do is also mark the individual trees. Now that of course would require a ground data collection exercise, and also precision RTK is required there, as I identified, because I've tried using a Garmin dual band GPS mapper device, and that just doesn't cut it. Once it's in QGIS, we can do a lot more analysis. The most basic being you have a demarcation of the boundary. This is how that looks. And this again, I've walked around with the Garmin GPS map device, so it does have some errors, but the errors are minimized to about 6 feet, so it's still usable. So later I'm going to take this other device, an RTK device, which is not yet proliferated in the market, but I will be using that to test out how I can mark the trees.